Hello, everybody. Welcome back. This is part 2 of section 1 of chapter 6. So this section is all about finding area between two curves. So whenever we do these kinds of problems, it's important to graph them and also see which graph is higher than the other graph, which graph is the top graph, which graph is the lower graph. So we are going to do the problem. For this problem, we are going to apply the same technique. The question is find the area between y equal to 1 over x and y equal to 1 over x squared and x equal to 2. This is problem number 13. So let's graph the first one, y equal to 1 over x. I have chosen some point like x equal to 1, then y equal to 1. When x equal to 2, y is 0.5. When x equal to 4, when y is 0.25. So I have drawn that graph in the color green. And then the other graph, this is the red one. Y equal to 1 over x squared. X equal to 1, y equal to 1. When x equal to 2, y is 0.25. When x equal to 4, y is 0.0625. So this graph is done in red. And you notice that in this part of the graph, and it also says that it's up to x equal to 2. But we also notice that this at 1, 1, it is the point of intersection for the two graphs. So 1, 1 is the point of intersection for the two graphs. We notice that in the table also. So in the part where it has the point of intersection x equal to 1 and x equal to 2, and we notice that y equal to 1 over x graph is the top graph and y equal to 1 over x squared graph is the bottom graph. So first we find out step 1 is to graph shown above. And in step 2, find out the point of intersection. We can also solve this algebraically. If you set the two equations to be equal, then it will become x equal to x squared if you flip both sides. This will mean x minus x squared equal to 0, or x times 1 minus x equal to 0, either x equal to 0 or x equal to 1. But x equal to 0 is not possible because that will make both graphs 0, undefined. So we are not going to plug in x equal to 0. So x equal to 1 is one point of intersection. And if you substitute x equal to 1 in either one of the two equations, so we get y is also 1. So x equal to 1, y equal to 1 is the point of intersection. The other lower bound, other bound for x would be x equal to 2, which is given in the problem. Now we want to evaluate the integral. Evaluate the area between the graphs. So it's a equal to integral x varying from 1 to 2, y top minus y bottom dx in this interval. In this interval 1 to 2, the top curve is 1 over x graph. The bottom graph is 1 over x squared dx. So it is integral 1 to 2, 1 over x minus x to the negative 2 dx. In order to integrate, we want to write like that. So integral of 1 over x is ln of absolute x, and the other one is x to the negative 1 over negative 1. So which needs to be evaluated between 1 and 2. ln of absolute x plus 1 over x, because it's negative and negative positive, x to the negative 1 will be 1 over x between 1 to 2. So it will be ln of 2, absolute value of 2 is 2, then plus 1 over 2 minus ln of 1 plus 1 over 1. Ln 1 is 0. So you get ln 2 plus 1 half minus 1, which is ln 2 minus 1 half. In this problem, it's also asked what is the, give a typical rectangle. So when we divide this 1 to 2 into number of subintervals, the ith subinterval will give us this strip, the ith strip. So where this ith rectangle would be of width delta x, and the height will be y top minus y bottom. The top one is 1 over x graph, and the bottom one is 1 over x square. So the difference would be the height. That would be the height of the rectangle. Delta x is the width of the rectangle. Let's say problem number 28. We have to find out the area between the two curves, y equal to cosine x and y equal to 1 minus cosine x, where x lies between 0 and pi. So we have to graph them first, and then we have to decide where the two graphs meet. So y equal to cosine x is the question, it's only drawn between 0 to pi. So we know that y equal to cosine x, it's going to look like this if you are considering between 0 to 2 pi. But we will consider only between 0 to pi. So we are going to consider only this part of the graph. We're only going to consider that part of the graph, which is given in green in the picture, because it's only between 0 to pi, not up to 0 to 2 pi. And 1 minus cosine x graph, we consider 1 minus cosine x graph. It is combination of negative cosine x and plus 1, correct? So this will be inverted or flipped reflection of the cosine x graph about the x-axis. And then it is shifted up 1 unit. So first we will be graphing. I'm only showing the rough sketch here. The actual sketch is here in this graph. So we are going to do the inverted graph of the function. I'm graphing the full one. Then it is shifting up 1 unit. So when it shifts up 1 unit, it becomes, so every point becomes shifted up 1 unit. Okay. So what was previously pi, when it was pi, then it is 1 minus, it is negative cosine pi. So negative cosine pi will be positive 1. So at 1, now that point becomes 2. So this point becomes, so pi comma 2. So I'm now combining the two graphs, the green one, which is cosine x graph in the interval 0 to 2 pi, with the red graph, which is between 0 to pi, which is 1 minus cosine x graph. So if I combine these two graphs, I get the graph as shown in the picture. So we notice that in the interval 0 to pi, in one part, it is actually the green graph is higher. The second part, the red graph is higher. So let's divide the area into two parts, A1 and A2. So the step number 1 is to graph the two graphs. cosine x and 1 minus cosine x graph in the interval 0 to pi. That part we have done. Then where do the two graphs meet? What is the point of intersection? That is obtained by setting the two graphs to be equal. So if you move all the cosine x to one side, you get cosine x equal to 1 or cosine x equal to 1/2, which means x equal to pi over 3. So the x equal to pi over 3 is the point of intersection. So that is where the two graphs meet when x equal to pi by 3. Then step 3, divide the area into two parts. Divide the required area into two parts. What we also do in this problem is we are taking the integral and absolute f of x minus g of x. That is what we are doing in this problem. So we are going to write a equal to a1 plus a2, the two areas. The first one, it is integral 0 through pi by 3, right? We're considering only up to pi by 3. Y top minus y bottom dx. The second part, it is from pi by 3 to pi. In that part, what is the y top minus y bottom dx? So it would be integral 0 through pi by 3. The top part for the first part is cosine x minus bottom part is 1 minus cosine x dx. The second part is from pi by 3 to pi. The top part is 1 minus cosine x, which is the red graph, minus the bottom one is the green one, dx. So we get, if you simplify, you get integral 0 through pi by 3. Then cosine x, you have cosine x minus 1 plus cosine x. So you get cosine x, 2 cosine x minus 1. If you simplify that, then integral pi by 3 to pi, this will be 1 minus 2 cosine x dx. So if I take the integral for each one of them, integral of 2 cosine x is 2 sine x minus 1, integral of that is x, between 0 and pi by 3. For the second one, integral of 1 is x, then minus 2 times integral of cosine x is sine x. That one is evaluated between pi by 3 and pi. Substitute, it is 2 sine pi by 3 minus pi by 3. Then at the lower limit, they are all 0. Plus upper limit, it is pi minus 2 sine of pi, upper limit. And minus at the lower limit, it is pi by 3 minus 2 sine pi by 3. So if you notice here, it is 2 sine pi by 3 minus pi by 3 plus pi. 2 sine pi will become 0 because sine pi is 0. If you distribute the minus sign here, it will be minus pi by 3 plus 2 sine pi by 3. If you combine the like terms, you get 2 sine pi by 3, 2 sine pi by 3. That will be a 4 sine pi by 3. Then you have pi minus 2 pi by 3. So pi minus 2 pi by 3. So if I minus pi by 3 will be minus 2 pi by 3. So pi minus 2 pi by 3, which will be plus pi by 3. But sine of pi by 3 is root 3 by 2. So the answer would be area equal to 2 square root of 3 plus pi by 3. Hope this video helps. In the second part of the video, we have done 2 problems. One is problem number 13 on the practice exam. And there is another one we have done, that is problem number 28 from the practice exam. There is another problem in the exercise which is done as a separate video. Please check that. This problem number 19, is done as a separate video. So in this section, we have, you have problem number 5 video, which is in the earlier part of the video. Then we have the video for problem number 13. And then problem number 19 is done as a separate video. Problem number 19 is done as a separate video. And then we have done in this video, problem number 28. Hope these videos are helpful.